Hi everyone, this is Tutor Marife MCP. I create math video lessons that could serve as your supplemental learning resources. In this video, I will teach you how to graph this given system of linear inequalities into variables and how to identify points that belong to the solution set of the inequalities. Let's start by graphing each of the inequalities in the system. We have y greater than or equal to x plus 1 and y less than negative x plus 1. For the first step, identify whether your borderline is a solid line or a dashed line. Look at the inequality symbol. If the inequality symbol has an equal component to it, use a solid line. If the inequality symbol doesn't have an equal component to it, use a dashed borderline. So for the first inequality, we have to use a solid borderline. And for the second inequality, we are going to use a dashed borderline. For the second step, replace the given inequality sign with an equal sign to obtain the related equation of the borderline. From the first inequality, the related equation is y equals x plus 1. And for the second inequality, the related equation is y equals negative x plus 1. The two equations are written in slope-intercept form or y equals mx plus b form. So we are going to use the slope and the y-intercept of the equation to sketch the borderline. There are actually three ways on how to graph a linear equation. One way is by finding 2 points, by assuming any x values and solving for the corresponding y values, plot those points and draw a line passing through the 2 points. Another way is by solving the x-intercept and the y-intercept of the equation, plot the intercepts, and sketch a line passing through the intercepts. Okay? In this video, we're going to use the slope and the y-intercept. Let's identify the value of the slope and the y-intercept. M represents the slope of the line. It is the numerical coefficient of x. In this equation, the coefficient of x is invisible and it's understood to be positive 1. So M is equal to 1. Any number has an invisible denominator of 1, so in fraction form, the value of the slope is 1 over 1. 1 is equal to rise, 1 is equal to run. That's why the definition of slope is the ratio of rise to run. If the sign of the slope is positive, the line is rising when viewed from left to right. The value of b is the constant term in the slope-intercept equation. It's actually the y-coordinate of the y-intercept. This is the constant term in the slope-intercept equation. B is equal to 1. Therefore, the y-intercept is at 0, 1. Let's use this information to sketch our solid borderline for the first inequality. First, plot the y-intercept. This is a point on the y-axis. And from this y-intercept, we move 1 unit upward and move 1 unit to the right. 1 rise, 1 run. This is our second point. Then let's draw a solid line passing through these two plotted points. This is the borderline of the first inequality. It divides the xy plane into two regions. This region, the upper region, and the lower region. We need to determine which of the two regions to shade. To determine which of the two regions to shade, we're going to use any point as a test point, and that point should be not contained by the borderline, okay? Usually the easiest test point to use is the origin because both the x and y coordinates of the origin are 0. Substitute x equals 0 and y equals 0 into the inequality and find out if we get a true or false statement. Left side becomes 0, right side becomes 0 plus 1. Simplify the right side, 0 greater than or equal to 1. Compare the two numbers. 1 is obviously larger than 0. And look at the open side of the inequality sign. If you're still confused with which of the inequality signs means less than or greater than, always remember that the open side of the inequality sign always faces the larger number. 1 is larger than 0, but the open side of the inequality sign faces 0 instead of 1. Therefore, this is a false statement. If we get a false statement, it only means that our test point doesn't satisfy the inequality. So we should shade the region that doesn't contain the test point. If this is the test point and this is the region that contains it, this is the correct region to shade. The one that doesn't contain our test point. Okay, let's shade the upper region. This is the graph of the first inequality. Let's now focus on the second inequality. We have y less than negative x plus 1. We should use a dashed borderline because there is no equal component to the given inequality sign. This is the related equation for the borderline. It is also written in slope-intercept form or y equals mx plus b form. Let's identify the value of m and the value of b. M is the numerical coefficient of negative x, and it's equal to negative 1. Any number has an invisible denominator of 1. In fraction form, the value of the slope is negative 1 over 1. The numerator is equal to rise, the denominator is equal to run. If the sign of the slope is negative, it means that our dashed borderline is a falling line when viewed from left to right. Okay? A negative sign in the numerator only means that we have to move down from the y-intercept instead of moving up from the y-intercept. The value of b is the constant term in the slope-intercept equation, and it's also 1. It's the same as the value of b in the first equation. So the y-intercept is the same for both equations. We have 0, 1. So this is also the first point for the second inequality. Okay? For the second point, we have to use the value of the slope. -1. So, from this point, move 1 unit down for negative. Then 1 unit run. This is the second point. Okay, then let's draw a dashed borderline passing through these two plotted points. And this is the borderline of the second inequality. It divides the xy plane into two regions. This is the upper region and the lower region. Let's identify which of the two regions to shade. Again, let's pick a point that's not on the dashed borderline, and let's pick origin as our test point. Replace x and y with 0, and let's find out if we end up with a true or false statement. The left side becomes 0. The right side becomes -0 plus 1. Simplify the right side of the inequality. It's 1. Compare the two numbers. 1 is larger than 0. Look at the open side of the inequality sign. The open side of the inequality sign should always face the larger number, and 1 is larger than 0, so this is a true statement. If this is a true statement, it only means that our test point satisfies the second inequality, and we should shade the region that contains it. If this is the origin and this is the region that contains it, we have to shade this region, the lower region. This double shaded region is the intersection region of all the solutions in the given system. It contains infinitely many points that satisfy not only one of the inequalities in the system, but both the inequalities in the system. This is where we're going to pick 5 points that belong to the solution set of the system. Okay, so let's pick our 5 points. For the first point, let's pick this one. The x-coordinate is -1, the y-coordinate is 1. Second point. The x-coordinate is -3, the y-coordinate is -1. Third point. The x-coordinate is -2, the y-coordinate is 2. Fourth point. The x-coordinate is -4, the y-coordinate is +3. And for the last point, how about a point on the x-axis? Let's pick this one. The x-coordinate is -5, the y-coordinate is 0. You can verify these points by substituting the x and y values into both the inequalities in the system, and you should end up with true statements. Let's verify one of the 5 points. How about -2 and 2? Let's check if this point satisfies both the inequalities in the system. So the first inequality is y greater than or equal to x plus 1. Replace x with -2, replace y with +2. 2 greater than or equal to -2 plus 1 is -1. Compare the two numbers. 2 is larger than -1. Look at the open side of the inequality sign. It faces 2, which is larger than -1. So this is a true statement. This point satisfies the first inequality. Let's double check if it also satisfies the second inequality. Y less than -x plus 1. Replace x with -2. Replace y with 2. Simplify the right side. Negative times -2 is +2 plus 1. 2 plus 1 is 3. Compare the two numbers. 3 is larger than 2. The open side of the inequality faces the larger number, so this is a true statement. Therefore, this point is a solution to the given system. That's it. If you have any questions, you want further clarification, or you want to give a feedback on this video, feel free to post your comments. Again, this is Tutor Marife MCP. Thank you for taking the time to watch my video.